Okay, so I want you to picture a standard Ethernet cable. You plug it in, you get internet. Simple, right? Now imagine a little metal box that costs $615, and its only job is to turn that connection into light, send it over a mile away, and then turn it back into a signal.
That is quite a specific job, but this isn't, a simple adapter you'd find at a big box store.
No kidding. Today we're doing a deep dive into the NTI E-FSC. It's a converter for RS485, RS232, and RS422 interfaces to fiber. But I see that price tag, $615, and I just have to ask, why? Why do you need to turn data into light beams just to talk to a machine that's, way down the road? Why not just run a really, really long wire?
Because, well, physics is cruel. If you run a standard copper wire too far, the signal it dies, it degrades.
It just fades out.
Completely. I mean, if you look at the specs for the setup, your standard CUT5, 5E, or 6 cables, they're strictly limited to a combined 1,000 feet. That's about 305 meters.
Okay, but 1,000 feet. It still covers a pretty decent-sized office building?
Yeah. An office, sure, but not a sprawling industrial facility or campus. And that right there is the aha moment with this device. By putting fiber in the middle, you smash that limit.
So we're not just talking a few extra feet.
No, not at all. This converter lets the signal travel up to 1.2 miles. That's 2 kilometers.
Wow. That is a massive jump. I mean, that's the difference between connecting a printer in the next room and connecting a sensor in a completely different building. But let's back up for a second. We're converting RJ45 signals to light.
Yeah.
What kind of fiber are we talking about here? The source mentioned simplex multimode. That sounds complex.
It sounds more complicated than it is. It's actually pretty straightforward. It just needs 2 simplex multimode cables, either 50 micron or 62.5 micron.
And multimode just means what?
It means the core of the fiber is a bit wider, so it lets light bounce around more inside. It's perfect for this kind of medium distance, like that 1 to 2 mile sweet spot.
Got it. And for connectors?
You've got your standard SE connectors on the fiber side, the snapping kind, and an 8-position terminal block for the copper wire.
So it's basically a bridge. But I have to play devil's advocate again. Is this all just about distance?
It's about survival. This thing isn't designed to sit on a desk in a nice air-conditioned server room.
Right.
If you need to run a cable a mile away, chances are it's going through some hostile territory. So this device has built-in surge and static protection.
Which is huge because copper basically acts like a giant antenna, right?
Right.
It just picks up all the noise.
Precisely. Imagine a lightning strike near a mile-long copper wire. That surge travels right down the line and poof, there goes your expensive equipment.
But fiber is glass.
Exactly, doesn't conduct electricity. So this unit inherently isolates the two ends from each other. And then you look at the temperature specs.
I saw that. -40 to 185 degrees Fahrenheit. That's extreme.
That's minus 40 to 85 Celsius. You can stick this thing in an industrial freezer or a baking hot desert solar farm, and it just keeps working.
Okay, that definitely justifies the industrial label. What about powering it? It's out in the middle of nowhere. Finding an outlet might be tricky.
They thought of that. It's very flexible. It can run on 5, 9, or 12-volt DC power. So you can often just tap into an existing power rail inside a control panel. No need for a separate bulky adapter.
And speaking of hooking it up, the material specifically calls out compatibility with EnviroMux units.
Yes, the E2D, 5D, 16D, and the eSIM S16, those are environmental monitoring systems.
So paint the picture for me. How does this all fit together in the real world?
Okay, imagine a massive warehouse or a remote utility station. You're using an EnviroMux system to monitor temperature, humidity, maybe water leaks. The NTI E-FSC is the lifeline that lets those sensors live very, very far away from the central computer that's collecting all the data.
It's almost like you're building a nervous system for a facility.
That is the perfect analogy.
Yeah.
It connects the remote nerve endings, the sensors, back to the brain, and it doesn't matter how far away they are or what the weather is like in between.
So to wrap this up, the NTI E-FSC isn't just a cable extender. It's a hardened industrial bridge that turns a short-range electrical signal into a long-range optical one, keeping data flowing reliably over a mile of potentially really nasty terrain.
That's it, exactly. It makes sure that critical sensor data arrives safely, securely, and without any interference.
It really makes you think about all the invisible infrastructure holding things together. So next time you see a massive factory or maybe a huge solar farm, just ask yourself, how are the sensors at the very far edge of that property talking to the control room a mile away? Chances are it's something a lot like this. Thanks for listening.